The next one is a structure module for loading the files required for the simulation, such as a technology file and a layout file. And in the condition module, there are 7 tabs. Users can set the simulation conditions. After all settings are defined, save the project file through output file, and then run the simulation. When using the TDeformX creator, the first thing to do is loading the files through structure module. A layer map is to load a technology file that includes layer information according to the layer number. GDS TDB file is to load the layout file. But if you have a previously saved project file, you can simply drag and drop to load it and then use it. In this training, it is for beginners, so I will create a new project file. In that case, please load a technology file and layout file, and then define the project file. I will use the simple example which is included in the tutorial. Just drag and drop the files or click this folder icon and then load them. Actually, loading the layout file is very essential. However, for a technology file, you can modify or create it through TDeformX Creator. I will show you how to do it. Click Tools and select Set Technology. If you want to create a new one, click this Add button. Define the layer name and purpose according to the layer number. And then click this Save As button. Like this, if you use the Set Technology function, even if there is no technology file, you can easily define and use it. Now, let's set up the simulation conditions. You can define the structure information in the Stack tab. Add or delete layers using the icons at the bottom. So, to add a layer, click this Add button. Enter the name and select the material type. In this case, I will enter A and select Insulator. Click OK button. You can see that the layer A is added. This green icon is called Drawn Condition, and you can define the properties of the layer in detail. The General tab is about defining the basic layer's properties such as thickness, planarization, mask setting, and etching process. The Advanced tab literally has advanced features. Since these are functions for creating more realistic structure, I will skip them in this training. If you want to know about them, please refer to the manual. Finally, Deformation tab. You can set the Young's modulus and Poisson's ratio of the layer. Enter the values only when you know the material's yield strength, initial stress, and coefficient of thermal expansion. To proceed with the simulation considering the value of yield strength, you have to click this Yield Strength option in the Deformation tab. And from now on, let's define the stack information of the example. Here is the stack information of the example. Add the layers to be used and define the layer name and type from layer A to G. Let's click the zone condition of layer A. You can modify the layer name and material type between insulator and metal. And select the substrate property. If the layer is stacked, select stack. If the layer is a substrate, select substrate. If the layer is being filled like LC, select fill. In this case, layer A is the bottom substrate, so let's select substrate. And change the thickness as 0.5. Division is to enter the number of divisions in the z-axis direction. As shown in the following figure, the shape of the sidewall may be different depending on the division value. And let's change the values for Young's modulus and Poisson's ratio. The information of Young's modulus and Poisson's ratio of all layers in this example are arbitrary values. So, when using TDeformX by yourself, please enter the values suitable for the characteristics of the layer. After that, click OK button. The next one is layer B. The substrate property is set to stack. The thickness is 0.3, so I will modify it. In this case, mask is used as C. If you want to identify this mask layout, please click on the Defining Area tab. There is a View Layout. Some people ask me that the mask design is not visible in the View Layout. In that case, if you click this option, there is OpenGL buffer. So by changing the state, you will probably see it. So if you use this view layout, you can check the mask information defined in the layout file and technology file. In the layer list, you can check the layer name according to the layer number. And if you click the mask C, you can turn on and off the mask C. And click the mask C and make other layers invisible. You can see only mask C. To briefly explain how to use the layout tool, if you want to zoom in or out, please press Ctrl key and move the mouse wheel. When moving up or down, Just move the mouse wheel. When moving left or right, please press Shift key and move the mouse wheel. To adjust the viewer screen automatically, press Ctrl key and alphabet F key at the same time. By right-clicking on the screen, you can add a text or rectangle object, or click the ruler to measure the distance. Therefore, please make good use of the view layout when you want to check the mask design for each layer. So I will select mask C. Also, you can choose the sidewall type among 8 taper models, like this. In the taper type, select one between angle and width. Depending on the taper type selection, the input value is set as angle or width for the taper value. But in this example, I will use the default settings. And let's change the Young's modulus. Actually, layer D has the same as layer B, except for the mask. So in this case, I will delete this layer D and I will just copy and paste it, and then just modify the layer name, and then I will change the mask as mask D. The next one is layer C. The substrate property is set to stack. Change the thickness to 0.5. The planarization option is used for this layer. This figure shows whether planarization is used or not. If planarization is checked, degree of planarization and gap position functions are also activated. Depending on the degree of planarization, the structure will be generated differently. For example, when the degree of planarization is 1, the structure will be perfectly planarized. On the other hand, when the value is 0, the result is generated like the conformer structure. In the gap position, set the position where the planarization option is applied. And there are 4 types: mean, max, relative position, and estimating position. If the gap position is selected as mean or max, the reference zone is activated. Also, when the gap position is set to relative position or estimating position, X position and Y position are activated. Since min and max options are frequently used, I will mention them in detail. Literally, min means that defines the thickness based on the minimum position, and max is based on the maximum position. The following example is easy to understand about the concept of gap position and reference drawn. At first, let's check the simulation conditions of layer C. The thickness is 1 micrometers. Set DOP as 1 to completely planarize, and gap position is max. On the left, the reference drawn of layer C is set to none. And on the right, reference drawn is layer A. Did you see the difference between the two? Please check the thickness of layer C. If the reference drawn is selected as none, the thickness is defined based on the top position of the layer immediately below it, in this case layer B. So here is the thickness of layer C, 1 micrometer. For the second one, as the reference drawn is layer A, the thickness is 1 based on the top of layer A. So it is 1 micrometers. Therefore, by utilizing those functions, you can control the planarization and thickness of a layer. For layer C, to completely planarize, I will set the DOP as 1, and gap position will be selected as max without reference drawn setting. It means that the planarization option is applied based on the highest position of the bottom layer, layer B. And for the Young's modulus, I will change it as 3000. And for the Poisson's ratio, I will use the default setting. After that, please click this OK button. And the next one is layer E. Layer E is totally the same as layer C, so I will copy and paste it. And then let's modify the name of the layer. Now we have 2 layers left, layer F and G. Looking at layer G first, substrate type is set to stack and thickness is 0.5 micrometers. And the patterning mask is used as B, which is negative type. So I will change the thickness and set the mask as B, which is negative type. If you check the mask through the view layout, it looks like a hole shape. This layer uses the onSelective Edge function. In TDeformX, there are some options about etching process. Most of all, I will talk about onSelective Edge, until drawn with stopper, and edge stopper. Let's see unselective edge and edge stopper first. Unselective etch means that the etching process starts from that layer. Then, etching proceeds until just before the layer for which the etch stopper is checked. To clarify the concept of two functions, let's look at the following example. The etching process starts from layer 3. It means that unselective etch should be checked for the zone condition of layer 3. And when you want to proceed with the etching process from layer 3 to layer 1, layer 0 should be an etch stopper because etching proceeds until just before the layer for which the etch stopper is checked. Therefore, the result will be generated like this. The next one is until zone. It is convenient to think of until zone function as a slightly more powerful etching process compared to the unselective etch. Unselective etch means that etching proceeds until just before the layer for which the etch stopper is checked. On the other hand, until zone performs the unselective etch process proceeds up to the layer specified by until zone. Even if there is a layer set as an etch stopper, between the layers designated as until zone, etching process is unconditionally performed. This example is easy to understand about unselective etch and until zone. Etch stopper no means that the etch stopper is unchecked. Also, etch stopper yes means that the etch stopper is checked. If the purple layer insulator 2 is selected in until zone, whether there are etch stoppers like insulator 3 or insulator 4, the etching process proceeds up to the layer specified by until zone insulator 2. Until zone with stopper is an advanced etching function. It means to perform the until zone process while considering whether to apply the etch stopper. Let's take a look at this example. There are two types of CNT mask. From insulator 1 to insulator 4, the etch stopper is unchecked. For CNT1, select until zone with stopper and click insulator 1 from the list. And when unselective etch is applied to the CNT2, the following structure can be created. Therefore, please utilize those functions related to the etching process depending on the desired structure type that you want. For layer G, unselective etch is used. For layer F, the etch stopper is unchecked. It means that by using the mask B, holes will be generated from layer G to layer F. So for layer G, I will check unselective etch. For layer F, I will uncheck the etch stopper. And for layer G, I will also modify Young's modulus as 5000. And let's check layer F. Substrate type is stack and thickness is 0.5 micrometers and Young's modulus is 10,000. So I will change the simulation conditions. Finally, we defined the properties of all layers to be used. Please check the manual for explanations of various functions not mentioned above.